Welcome to part 2 of this series. In this video, we'll cover the development environment, execution environment, and fully integrated and visual tooling. One of the most popular current development environments that data scientists are using is Jupyter. Jupyter first emerged as a tool for interactive Python programming. It now supports more than 100 different programming languages through kernels. Kernels shouldn't be confused with operating system kernels. Jupyter kernels are encapsulating the different interactive interpreters for the different programming languages. A key property of Jupyter Notebooks is the ability to unify documentation, code, output from the code, shell commands, and visualizations into a single document. Jupyter Lab is the next generation of Jupyter Notebooks, and in the long term will actually replace Jupyter Notebooks. The architectural changes being introduced in Jupyter Lab makes Jupyter more modern and modular. From a user's perspective, the main difference introduced by Jupyter Lab is the ability to open different types of files, including Jupyter Notebooks, data, and terminals. You can then arrange these files on the canvas. Although Apache Zeppelin has been fully re-implemented, it's inspired by Jupyter Notebooks and provides a similar experience. One key differentiator is the integrated plotting capability. In Jupyter Notebooks, you are required to use external libraries. In Apache Zeppelin, plotting doesn't require coding. You can also extend these capabilities by using additional libraries. RStudio is one of the oldest development environments for statistics and data science, having been introduced in 2011. It exclusively runs R and all associated R libraries. However, Python development is possible, and R is therefore tightly integrated into this tool to provide an optimal user experience. RStudio unifies programming, execution, debugging, remote data access, data exploration, and visualization into a single tool. Spyder tries to mimic the behavior of RStudio to bring its functionality to the Python world. Although Spyder does not have the same level of functionality as RStudio, data scientists do consider it an alternative. But in the Python world, Jupyter is used more frequently. This diagram shows how Spyder integrates code, documentation, visualizations, and other components into a single canvas. Sometimes your data doesn't fit into a single computer storage or main memory capacity. That's where cluster execution environments come in. The well-known cluster computing framework Apache Spark is among the most active Apache projects and is used across all industries, including many Fortune 500 companies. The key property of Apache Spark is linear scalability. This means if you double the number of servers in a cluster, you also roughly double its performance. After Apache Spark began to gain market share, Apache Flink was created. The key difference between Apache Spark and Apache Flink is that Apache Spark is a batch data processing engine, capable of processing huge amounts of data file by file. Apache Flink, on the other hand, is a stream processing image, with its main focus on processing real-time data streams. Although Engine supports both data processing paradigms, Apache Spark is usually the choice in most use cases. One of the latest developments in the data science execution environments is called Ray, which is a clear focus on large-scale deep learning model training. Let's look at open-source tools for data scientists that are fully integrated and visual. With these tools, no programming knowledge is necessary. Most important tasks are supported by these tools, with tasks including data integration, transformation, data visualization, and model building. KNIME originated at the University of Constance in 2004. As you can see, KNIME has a visual user interface with drag and drop capabilities. It also has built-in visualization capabilities. KNIME can be extended by programming in R and Python and has connectors to Apache Spark. Another example of this group of tools is Orange. It's less flexible than KNIME, but easier to use. In this section, you've learned about the most common data science tasks and which open-source tools are relevant to those tasks. In the next video, we'll describe some established commercial tools that you'll encounter in your data science experience. Let's move on to the next video to get more details.